Hello everybody and welcome to today's webinar. Just a few notes to mention first. So you are all muted. If you do have any questions as we're going through the webinar, you can type them into the question box, and at the end I will go through those questions and hopefully answer them. Just note as well that all of our webinars are recorded. So these are then freely available for you to view online through our website afterwards. So this webinar will be put online as well. Okay, so we'll make a start. So my name is Gavin Newlands. Welcome to the webinar today. Thank you for joining. Today I'm going to be talking about version 16 of Primer, which is our most recent release. It was released in March of this year. So I'm going to go through some of the new features that you'll find in version 16. So first of all, just a review of our most recent releases. If you haven't moved to version 16 yet, you're probably using version 15.1. That was released in October of last year. And as I said, version 16 was released in March of this year. So in terms of LS-DYNA keyword support, version 16 supports everything up to and including R11 of LS-DYNA. So all the keywords that you'll find in volumes 1, 2, and 3 of R11 are fully supported. I first wanted to mention a few things that will help you if you're a new user for Primer. So first of all, there's lots of tutorials that are available through the help menu. So if you go to help tutorials, there's a list of tutorials there, and they're in a variety of different subjects. So it's a good place to look first for help in a particular tool that you're looking at using. These tutorials are also available on our new website. So if you go to training tutorials, you'll be able to download all of those tutorials as well. And I've also already mentioned this, webinars. If you go to training webinars, you'll see a list of all the upcoming webinars, but you'll also see the past webinars. And so these are recordings of these webinars. So this will go up there in a few days. And there's also lots of past webinars on a variety of different subjects. So it's a good place to look if you're looking for information on a particular feature, such as spot welding, model build, occupant positioning, that sort of thing, model checking. There's webinars in there on those subjects. So the first thing I want to talk about is keyword input and output of LS-DYNA. And we're constantly looking at ways of speeding things up in terms of reading and writing of models. Models are getting bigger, much bigger, and it can take a while to read and write those files across the network. Now in version 15, we introduced a binary file format. So this is another way of reading and writing model data, and it's stored in a binary file. The reason for using a binary file is it stores a lot less space. It takes up a lot less space than the normal keyword ASCII file, but it's also much quicker to read that information in and out across a network. So you get great speed ups from using the binary file, as you can see by looking at these charts. So if we're looking at writing ASCII here, these bars in the middle, compare that with the right binary. The right binary is much, much quicker. So this is writing the same file across a network. Now, as many people probably won't use the binary file and want to keep using the normal ASCII keyword file, we've also put some effort into improving the speed of reading the normal ASCII keyword file. And if you look at this central bar chart, you can see blue is version 14, red is version 15. We made it pretty much twice as fast, and we've made it more than twice as fast again in terms of writing a keyword file across a disk. So it's much, much quicker now, and we will continue to make these improvements because models are just getting bigger, and you want to be able to handle those models in a reasonable time in Primer. A few other improvements to input and output. So last version, version 15, we also introduced the ability to read and write natively zipped format files, so gzip or winzip files. That's a lot quicker than it was in version 16 compared to version 15 now. You can also now read encrypted zip format files. So if you receive an encrypted zip format file, you can read that directly into Primer. Primer will prompt you for the password, and you can type that in. So other improvements for larger models. These improvements that I'm talking about here apply to models of all sizes, but will become more noticeable for models with more than 10 million elements and nodes. So the response to change in graphics is faster. So that's generally the moving around of models, blanking, unblanking, selecting things. That is at least 2 times faster in version 16 compared to version 15. And if you do a lot of cut sections in your model and you drag those cut sections through your model, the speed of dragging a cut section is dramatically faster as well, so greater than 5 times faster. Okay, so moving on to some of the tools to help you create and modify your model. So first thing is geometry mesh. So you'll know that Primer isn't a full meshing tool, but it does contain some meshing capabilities to help you modify your model. So these include remesh area, where you can select an area of mesh and remesh that to a particular element size. We also have the creation of swages. So stiffening beads or swages you can create and mesh. Spot weld heat affected zone remeshing. So this is when you want to create spot welds that are meshed in and have one or more rings of elements in a different part with different material properties that represent the heat affected zone around the spot weld. So that requires local remeshing of the mesh, and Primer can now do that. Creation of hole creation and removal is in there. Creation of standard mesh shapes, plates, blocks. We have a built-in tape mesher and so on. Now, as well as those, we also have the ability to mesh surfaces, so you can create shell mesh on surfaces. We've had this in Primer for a few versions, but it has some limitations. So usually when you read a CAD model into Primer, it's split up into lots of different surfaces. Like you can see here, all the different colors of this CAD file represents all the different surfaces. And when you mesh that in Primer, it meshed all those surfaces individually. And so you could end up with mesh transition problems, as highlighted in the bottom right-hand corner here. In version 16, we've sorted that out so that you don't have these mesh transition problems through surfaces. So I'll just show you a demonstration of this in Primer. So I've got this exact model. So it's a CAD part, and I've got some surfaces on here, little different surfaces. If I go to Mesh Geometry, I can specify the part ID I want my mesh to end up in, part 1. Specify element size. This is quite a large element size in this model because this is actually a model from a building rather than a vehicle. I'm going to select all the surfaces. Click apply. Now, hopefully you can see, I'll not move it around too much because there might be some latency across the internet. But hopefully you can see the outer boundaries of this part, this component, has been highlighted in blue. The inner boundaries are highlighted in grey. Now I can, if I want to, click on those inner boundaries and they turn red. And that means that those inner boundaries will be retained when I mesh this component. I can right click to turn those off again. That's the joints between these surfaces, but I can also select vertices as well. So I'll just click apply. This gives me a visualization of what the mesh will be. I can confirm that. And if I now just turn off my geometry and have a look at the mesh, this is the mesh that's being created. So it's fairly easy now to read in some CAD into Primer and throw a mesh on it. I'm going to move on now and talk about some of the Occupant tools in Primer. So as many of you will know, Primer contains many tools that aid the setup of an occupant analysis. So that includes dummy positioning, seat mechanisms and moving of seats, seat squash and seatbelt creation and fitting. Now, more recently, simulation-based dummy positioning and seat squash has become the norm. So this is creating an LS-DYNA analysis. And you run the analysis, and within the analysis, the occupant will be positioned or the seat will be squashed. At the end of the analysis, you take the final nodal coordinates and update your original model, and that's what you put into your crash model. So the advantages here are you can avoid initial penetrations that can occur during traditional dummy positioning within a preprocessor. The simulation takes into account all the internal material properties and contacts defined in the occupant seat model, so it's more realistic. And simulation-based positioning is required really for the more detailed human body models, so thumbs models and that sort of thing. And Primer contains tools that allow you to set up simulation-based positioning analyses. So this is what we had in version 15. So there's two analyses being set up here. On the left-hand side, now there might be a slight lag over the internet, so I apologize for that, but these are two animations from an LS-DYNA analysis. On the left-hand side, we've got the occupant being positioned into the seat and the arms and legs moving into the final position at the same time in one stage. On the right-hand side, we have two stages where the occupant is hovering above the seat and the arms and legs move into position, and the whole occupant moves down into the seat as a second stage. So setting up these types of positioning analysis was possible in version 15. Now in version 16, we've added the concept of multi-stage positioning. So instead of just being able to set up one or two stages, you can set up any number of stages. So you get to this through the dummy and seat squash tool. Instead of just one stage and two stage, you can select multi-stage. And here you get a whole list of, you can add as many or as few stages as you want. Okay. Now another thing that we've added into this is the ability to write a dyna.in file at the end of any stage. Now, if you don't know what the dyna.in file is, this is a file that's produced at the end of the analysis, which contains the updated nodal coordinates from the end of the analysis. So you can then import that back into Primer to set up your crash model with your occupant in its final position. What we've added in here is with multi-stages, you can now specify at the end of each stage, any stage, to produce a dyna.in file. And I'll explain how that is beneficial on the next slide. So let's say we are setting up multi-stage positioning all in one analysis. So this is one analysis, remember. The first stage, you might want the occupant to, the occupant starts above the seat, and the first stage might be to move it into the seat. Then you might want to move the arms into a position either side of the steering wheel. Then you might want to move the hands onto the steering wheel. Then you might want to move the feet onto the pedals. Now, in reality, in your analysis, the feet might be moved onto the pedals at the same time as the hands are moved onto the steering wheel. But these diagrams are just for explanation purposes. Now, at the end of stage 5 here, the middle one, you can see we're in our final position, so we can produce a dyna.in file then. But let's say you also wanted to try the hands on a different position on the steering wheel. You can continue your analysis and move the hands up a little bit, and at the end of that stage, produce a dyna.in file. And you can do as many of these as you want, all in one analysis. So this next slide shows you the animation from the previous setup. So the occupant moves down to the seat, the hands move up either side of the steering wheel, and then they move onto the steering wheel. And then the feet move into their pedal position. Then we produce a dyna.in file that can be input into your crash analysis. The hands move up onto a new position to the steering wheel. We produce another dyna.in file. Okay, so it's very possible now to produce one analysis and get multiple final positions out of that one analysis, because these analyses can take a reasonable amount of time to run. So it's good that you can get multiple final positions out at the end of those analyses. And then that means you can set up multiple crash analysis with your occupant models in slightly different positions. Just a reminder that these methods can be used for human body model positioning. So this is a animation showing the thumbs model being positioned into a seat and the arms and legs being moved into a specified position. And this is another thing that was added. This was actually added into version 15. So if you're interested in looking at the positions of fingers in dummy models, we've included a script that makes it easier for you to position fingers, because when you receive a dummy model, generally the whole hand is in one assembly, which means it can move around on the wrist, but the fingers can't move independently of the hand. So we've added a script that allows you to easily set up separate assemblies for these fingers, and that means you can move the fingers around independently of the hand, and that means you can set up positioning analyses to move the hands onto the steering wheel and maybe grip the steering wheel as well. Right, I'm going to move on now and talk a little bit about connections in Primer. So just as a reminder, if you don't use the connections tools in Primer, Primer contains powerful tools for creating, managing, and editing various connection types. So these types include spot welds, either beams or solids, adhesive. So this is either strips or runs of solids, as well as areas of solids, patches. Bolts, which are really combinations of rigid entities and beams and joints. And then there's the concept of the library items. This is where you can create your own library of connection types. And then Primer will read those and apply them and connect them in at lots of different locations that you specify. So it's very easy to create your own library item and then apply it thousands of times in your model and change it to something else at the click of a button. So the benefits of using the connections tool in Primer is easy one-click creation of all entity types, the ability to create many connections in one operation, either through intelligent detection of panel edges. So if you don't have any information to start with, Primer can create connections automatically according to where all the edges of your panels are. Or you can read in a file containing connection information and automatically create thousands of spot welds or lots of adhesive runs. You can manage and remake connections with an easy-to-use table. And comprehensive creation and checking of contacts used to attach connection FE to panels. So Primer can be used to manage and create all the tied contacts necessary to attach in your spot welds and your adhesive. Now we also have the ability to create and modify connections through our internal scripting API. So creation and modification of connections can be easily built into an automatic process, for example, using that scripting language. Now in version 15 and previous versions, it was only possible to create connections between shell parts. So this is just an example of a body in white that I connected together with adhesive runs, but all the parts in this body in white are shell parts. In version 16, it's now possible to connect to solid parts and NURBS parts as well. Now I'll explain a little bit about NURBS parts later on. But let's just concentrate on shells and solids. I'll just show you an example of this. So here I've got an example model. This is a floor of a vehicle. Now the blue part, the light blue part, is a shell part. So this is made of shell elements. The light green part is made of solids. So if I just zoom in a bit, you can hopefully see that they are made of solid elements. And some people are beginning to use solid elements more when modeling these type of panels. So if I go to connection, create, all the visible parts I'm going to try to connect together. Actually, no, I'm going to read in a connections file. So if I go to connections read, I've got an XML file here. And if I read this in, this contains some connections, and hopefully you'll be able to see these connections have been created. If I just blank this green part and zoom in, you should be able to see these solid nugget spot welds have been created and projected between the shell surface and these solid parts. Up here, this has got some adhesive that's joining this part on. So you've got a run of adhesive here that's been created and again projected to the surface of the solid parts. So fairly easy now to create connections between shells and solid parts. Now I'll just move on now and talk about morphing a little bit. So this builds on what we added in version 15. So in version 15, we added a new interactive morph tool. And the idea here is that you create a bounding box around some mesh. And then when you interactively change the size and shape of the box, that in turn will change the size and shape of the mesh. Okay. Now, I'll just demo what we've changed in version 16 compared to version 15. So I've got a very simple model here to show it. So I've got two cubes. Okay. Now if I go into Mesh Tools, Morph, hopefully you can see on your screens that we have these red boxes and green control points around these cubes. Now the left-hand side here is what was possible in version 15. So if I now try and morph this box, you can hopefully see how it morphs. So you've got the morph points in the corner points here, and I can drag the edges, I can drag the faces, and morph the shape. Okay. Now what we've introduced in version 16 is the concept of a higher order morph box. This means you can create more morph points along any of the edges. So here you can see I've got 4 in all 3 directions. Now what this means, if I just try morphing one of these control points and I look at the side, you can achieve much smoother shapes compared to what you could achieve before in version 15. Yeah. So if I now try morphing central face here, for example, you can see what is now possible. And there's various options related to these higher order boxes. I can put on interpolation and get something similar to what we had before. See, all these points are now being interpolated as I move them around, and so on. So there's a lot more control, a lot more possibilities with morphing now. I'll just show you another example of this. Here I've got a probably more realistic example. I've got a side panel from a vehicle with a B-pillar in there. If I go again to morph, I've already got a morph box set up in this model. A higher order morph box, so I've got a few control points in these 2 directions. I've got 4 in this direction, 4 in this direction, just 1 in this direction. If I drag this, you can see I can fairly easily change the shape, size of this B pillar. I've squashed it there in a couple of directions and moved it more outboard. So fairly easy to do this. And then these morph boxes, when you write the model out, they're saved with the model. When you read it back in, they'll be available for you to continue to morph it. So as I said, you can create as many of these extra control points in each direction as you wish in a local coordinate system or global coordinate system. And it gives you a lot more options when you're trying to morph your mesh into a particular shape. Let's go back to slides. A couple of other things we've added in for morphing. We've introduced the concept of a morph flow. Now what this is for all of these control points, you can specify a vector essentially. And what this allows you to do when you have specified these vectors, you can then parameterize your model essentially. And this helps you feed your model into something like LS-opt, where you can reference these morph flows and morph your model using LS-opt. Now I've got a simple example here to try and explain this. Let's say you have a crust tube. Let's say you have a crust tube that looks something like this. You've got two parts to it, which are different material properties, and you want to optimize the length of these two different parts to achieve a particular energy absorption target. So what you can do is you can create, first of all, a morph box around those parts. And here we've got a higher order morph box because we've got points in the middle. Then you can create morph flows, so these vectors on these central points. You can then feed that information into LS-opt, and that will then be able to morph your design and create lots of different models while it's trying to achieve the targets that you have specified. Now, there's a lot more information related to that and how to set it up and use it. And so if you look in the tutorials in Primer, you'll find particular tutorials on morphing optimization and morphbox, higher order morph boxes as well. And it will tell you how to use them and how to set it up to work in LS-opt. Now, finally, with morphing, I mentioned before we have an internal scripting language. We've added morph boxes, morph points, and morph flows into our scripting language API. So that allows you to create and modify all these things as using a script, which means you can potentially build morphing into an automatic process as well. So moving on to model check and output. So model checking. So checking of your LS-DYNA model continues to be an integral part of Primer. So just to summarize what the main checking tools are here. So if you go into model check and click apply, that's the main model check. That's around 7,500 individual entity checks in version 16. The dyna output button that allows you to interrogate errors and warnings in the LS-DYNA output files, and I'll talk a little bit more about that in a minute. Element quality is just simply for looking at the element quality checks. And then the dashboard check is something we introduced in recent versions to give you a visual view on the health of your model, and I'll show you an example of that in a minute. But with all these checking tools, customization of the checks is very important and becoming a lot more popular. And there's various ways in which you can customize these checks in Primer. First of all, the main model check. You can add your own checks into that via our scripting language. So you can add your own checks on nodes or parts or whatever it may be, and they will appear in the check tree along with every other check that we have. Under the options button on this panel, there's lots of different ways that you can turn on or off or modify internal checks. The dashboard check has the ability to add your own checks in as well, and I'll show you an example of that in a minute. You can turn off checking of specific entities or includes using the buttons on this panel. And then you can configure checks by reading custom preferences or error configuration files at the bottom here as well. So this is what the dashboard looks like. So the dashboard allows you to get a visual representation on the health of your model. So you get different tiles basically, and each of these tiles represents a different thing. So the first one is element quality check. The second one is the main model check. The third one is the dyna output check, where it's looking in the dyna output files for errors and warnings and so on. Now all the ones at the bottom here, you can add as many or as few of these as you wish. So these are company specific checks. So you can see here's an example, control cards. Control cards match company guidelines. Now behind every one of these tiles lives a script in our scripting language where you can check for whatever you want in your model and return back whether this tile should be green or red or whatever it may be. So you can have, as I said, you can add as many as a few of these as you want, and they aim to be company-specific checks that you want to check for to make sure that your model conforms to your internal guidelines. Just talk a little bit about element quality checks. We've added a couple new element quality checks in version 16. So one is max taper, which applies to shell quads. And another one is TED collapse, which applies to solid tetrahedron elements. as well as checking your model to see what passes your criteria or not. You can contour these as well through the normal contouring buttons. There's a couple more contouring options being added in there as well. This relates to any output from a forming analysis. So percentage thinning or percentage remaining, you can now contour that as well. So I mentioned this previously. So the LS-DYNA output file reader, Primer can read errors and warnings from the standard LS-DYNA text output files. So these are files like D3HSP or the message files. When you initialize your model, any errors and warnings that Dyna finds in your model will be written into those files. So Primer, you can read those files and produce a tree that looks something like this. And it mines out information on the entities referenced by those errors and warnings. What it means is that you can directly sketch or do an only on the entities that are referenced. You can easily see where they are. So it's a very quick way of investigating those errors and warnings. So here we've got an example where we've got termination due to out of range moments, and these are nodes that are referenced in that error message, and you can directly access those nodes from within this panel. A couple of things we've added into version 16. We've added an additional search. So this is, people told us that quite often they will automatically rename the standard output files that come out of LS-DYNA, like D3HSP message files, to another name. So we now search for more combinations of those strings, but we also have added in an additional search where you can search for any file name that you want, and then you can read information from that file. We've also added in compressed search. So this is, people told us that quite often they will automatically zip up the output files from LS-DYNA. And so we've added in a way that you can pick up those zipped files and read those in natively, so you don't have to unzip them before Primer can read them. One other thing we've added into this, so we look for errors and warnings and termination messages, but now we've added in time step information. So this allows you to view and sketch the entities referenced in the 100 smallest time steps messages that are in the D3HSP file. So again, just a quicker way of investigating that information. One other thing to mention with undo, so undo for renumbering. For a while now, we've had a general undo button at the top of Primer, which will undo lots of different operations. One thing that was missing from it was any sort of renumbering operations, so when you renumber your model in any way. So that's now been added in. So you can now undo any sort of renumbering operation. So again, looking at the increasing model size aspect, model checking is something where you are checking every single entity in your model, and the more entities you have in your model, the bigger the model is, the longer it's going to take. So we put some effort into making this quicker. So generally, model checking should be 20% faster in version 16 compared to version 15, but that is very model content dependent. It should be substantially quicker, maybe twice as fast, for models containing many solids and thick shells when these are used in tight contacts. And the second point here, for models containing many adhesive and spot weld connections. So anything where you've got solids and things like that, which are connected via tight contacts, when you're checking those, should be a lot quicker. And it also helps when using generally using the connections tools in Primer. So when opening the connections table, things like that, that generally does some checks, and those should be a lot quicker now. So I'm just going to finish off by talking about some of the more recent features in LS-DYNA and how Primer can help you with those. The first thing is isogeometric analysis, IGA. So just a little introduction if you don't know what isogeometric analysis is. So it's an alternative to standard finite element analysis, and it allows you to create an LS-DYNA model directly from the CAD without the need for meshing. So the standard route you probably go down at the minute is you have your geometry here, you'll mesh that, you might refine that mesh, and you go down this route. Now the isogeometric analysis route is that you start off with your CAD, and you convert that CAD into NURBS data that DYNA understands and can use its models. Excuse me. So what are the advantages of isogeometric analysis? Well, reduce model setup time. So the mesh creation and modification refinement, they're removed from the model build process. The analysis uses the same surface definition as defined in the CAD, rather than an approximation, which you'll always have with mesh. And it helps prevent the separation of CAD and mesh. So in terms of Primer support of isogeometric analysis, the Primer fully supports all keywords associated with IGA. Primer can visualize trimmed IGA surface data in the same way as a traditional mesh. Primer can be used to check IGA keyword data. It can be used to carry out contact checks between NURBS surfaces and NURBS and shell surfaces. And Primer can be used to create connections between NURBS surfaces. So you can create a model which is a combination of NURBS surfaces and normal traditional mesh, shell mesh surfaces as well. Generally, you would use the keyword element shell NURBS patch to create parts components in your model, and then those would be trimmed using defined NURBS curve to cut holes in and trim the edges and so on. And the keywords look something like this. So Primer version 16 can now display these surfaces. So let me just show you an example of this. So this is an example of a model where we have a component here which is set up using isogeometric analysis keywords. So if I go to the part tree, click on contents, it gives me a list of all the keywords that I have in my model. And you can see here I've got one element. Hopefully you can just about see that I've got one element. And that is a shell NURBS patch. If I right click and edit that keyword, this is now the element keyword that defines that component that you see on the screen. So there's lots of parametric data, there's lots of nodes that are the control nodes that define the shape. And at the bottom here, we've got lots of curves that are mentioned, are referenced, which trim it. Now, if I turn those off, turn off the trimming of it, update element, you'll see what it looks like in its untrimmed state. So you can see how the outer edges have not been trimmed, the holes have been filled in, and so on. I've got another example here. So this is of a B pillar again. And if I look at part tree contents, again, here I've just got 5 elements in here, so one each of these different components. Now, as you can see, you can visualize this data in Primer, but you can also create connections between these different components. So if I go to connection, create, connect together what's visible, I'll create some spot welds. Let's create some 4-hexa spot welds. If I just click here, if I zoom in, hopefully you can see, blank that, hopefully you can see that Primer has created some solid spot welds projected to the NURBS surfaces, and then they can be connected in via tie contact. It's quite easy for you to create models, isogeometric models, and connect them together now, visualize and connect them together now in Primer. The last thing to mention is ICFD setup. So the more recent versions of LS-DYNA, they contain different solvers that can be coupled together. The advantage being one model can be used for different analysis types and problems. And all the keywords that relate to these solvers can be found in volume 3 of the LS-DYNA keyword manual. And they include the keywords for the 3 main solvers, which is compressible flow, incompressible flow, and electromagnetism. But knowing which keywords to use for each of these solvers can be a bit of a barrier to using them. So how do you know which control cards to use and so on? So in Primer, there's now a tool to help create an ICFD analysis from the basis of a standard LS-DYNA structural model. So it looks something like this. You get to it from Tools, ICFD Setup. You get a panel that looks something like this. There's a diagram on the right-hand side, and you've got some inputs on the left-hand side to help set up the model. I'll just show you an example of this. So here I've got a sphere. Let's say I wanted to create an ICFD analysis on this sphere. So if I go to ICFD setup, I get the panel that I showed you before. Now, the top panel is currently grayed out, top part on the left-hand side. This is to allow you to automatically create some far-field boundaries which are required for this type of analysis. Now, you might already have those in your model, but I don't, so I'm going to create those. So I'm going to turn that on. I'm going to pick my central part, and I'm going to specify how far in different directions I want my far-field boundaries to be. So just input those parameters and generate. Essentially, this is, as you can hopefully see, created a mesh around the sphere. Okay. Now the next thing is to specify where the inlet is, where the outlet is, and all this sort of stuff. So if I specify the inlet as the part on the left-hand side, and specify my velocity in, I can specify my outlet on the right-hand side. Here you can see I want to specify my slip walls. So let's select multiple slip walls, which are these walls around the outer edge. And then I want to specify my no slip wall, which is the bit in the middle, which is my sphere. And there's a few other options you can specify in here to do with the fluid properties and so on. These are by default set to air. But then I click on generate. It tells me all the keywords that have been created. And if I look in my model list, you can see I've got model 1 and model 2. Model 1 is my original model. Model 2 is my ICFD model. Now, if I look at the part tree, and again look in contents mode, these are all the keywords that are in my model 2. You can see there's lots of different keywords that you won't be familiar with. So ICFD boundary, free slip, no slip, prescribed velocity, ICFD control cards, ICFD materials, ICFD parts, star mesh. So these are all keywords that are included in volume 3 of the LS-DYNA manual, and you don't have to know which ones to use. This tool just creates them for you. So if you now write that out and run it in LS-DYNA, you'll get something that looks like this. So this is the output from that analysis that I've set up. The animation might be a bit jerky over the internet, but hopefully you can see that we've created a simple CFD analysis based on just a single sphere at the starting point. So that's it. That brings me to the end of the webinar today. So just to summarize, version 16 was released in March 2019, so it's available now. So if you don't have it, you can download it from our website and start using it. Please do visit our new website, arup.com/dyna, for information and support, particularly looking at things like tutorials and webinars, which are now available for you to view. And also, if you want more information about what's being included in version 16 of our software, if you go to help, what's new, that links you to a PDF where all the things I've been talking about today are explained in a lot more detail. So that brings me to the end. So thank you very much for attending today and listening. I'll just check to see if we've had any questions come through. No questions have come through, so there's no questions to answer. So once again, thank you very much for your attention today, and we will bring the webinar to a close. Thank you.